Question 1. State the gradient in y equals 4x plus 7. If a linear expression is in the form of y equals mx plus b, the m number is the gradient. So in this case, m is the slope of the line or the gradient of the line. Once it's in that format, and this question was already in that format, so we can just pick out that the gradient is 4. Question 2. State the y-intercept in y equals 3x minus 4. With y equals mx plus b, the number that's in the b spot at the end there, that's the y-intercept. So b is the y-intercept if the linear expression is in that format, and this one already is, which is nice. So we can just pick out that the y-intercept in this case is minus 4. Question 3. State the gradient in 3x plus y minus 2 equals 0. Alrighty, we need to rearrange 3x plus y minus 2 equals 0 to be in the y equals mx plus b form, so that we can read off whatever number is in the front of the x part once it's in that format, and that'll be our gradient. So let's rearrange that so it's in the right format to allow us to just read off the gradient, because at the moment it's not. We want y on its own, so we're going to move the numbers away from the y side to leave it on its own, and then it'll be in the right format to read off the gradient. So we're going to move a 3x, which is a positive 3x, so we're going to subtract 3x from both sides. On the left hand side, the 3x and the minus 3x will cancel out, leaving us with just the x minus 2 part, and that minus 3 has moved to the right hand side really over there, or the 3x has become minus 3x on the other side. So 0 minus 3x can be just written as minus 3x. Now we want to move the minus 2 by adding to both sides, leave y on its own. We get minus 3x plus 2, they're not like terms so they can't join each other up, but we're in the right format now for y equals mx plus b, because m is the gradient we're looking for, and that's the number that's in front of the x once it's in the right format. So we can find that the gradient here is minus 3. Question 4. State the y-intercept in x minus y minus 7 equals 0. Okay, one way to do that is to use the rule that says the y-intercept of a line occurs when x equals 0. Alrighty, so when x equals 0, if we substitute that value of 0 in where the x is, we get this so far. So we then just get the minus y minus 7 equals 0. We'll want to get y on its own. we'll plus y both sides. This is one way of doing it. On the left hand side it'll cancel out and leave us with -7. On the right hand side we'll have the y, and we can just swap places there, so the sides swap over, so y equals -7 there. So we've substituted in x equals 0 to find the y-intercept. And so the y-intercept in this case was -7. Question 5. State the y-intercept in 5x minus 2y plus 10 equals 0. The y-intercept of a line occurs when x equals 0. When x equals 0, 5 times 0 is what we get when we substitute 0 in wherever there's an x. And we can write the rest out there. 5 times 0 makes 0, so that just leaves us with minus 2y plus 10 equals 0. We'll want to get y on its own. So we'll plus 2y both sides, leaving us with plus 10 on the left hand side equaling 2y. We'll divide by y both sides, leaving us with 5 equaling y, or y equaling 5. So we just process that to get y on its own once we've substituted in x equals 0. So our y-intercept in this case is 5. Question 6. State the gradient in 3x minus 2y equals 8. Right, we can rearrange 3x minus 2y equals 8 to be in y equals mx plus b form, and then we can read off just the m part, which becomes the gradient, but it's got to be in the right format first. So let's try and get it into that format. We want a positive y value, so let's plus 2y to both sides first. On the left hand side, the minus 2y and the plus 2y will cancel out, leaving us just with 3x. And on the right hand side we'll just write out 2y plus 8. They're not like terms, so they can't join together or anything like that. We just write them out. We want y on its own eventually, so let's move the plus 8 by minusing 8 both sides. On the left hand side we can write that out. They're not like terms, so they just get listed. 2y is on the right hand side because the plus 8 and the minus 8 sort of cancelled. And we want y on its own totally. Well, firstly we'll swap sides, so we'll just swap those around. We want y on the left hand side in the end anyway. And then we'll want to move the 2 by dividing 2 by every term. We've got to be careful with that. 2 divided by 2 in the left hand side leaves us with a 1, so we get y on its own. And 3x divided by 2 can be written as 3 on 2x. And then minus 8 divided by 2 gives us minus 4. Now, at least that's all in the right format. It took us a while, but we got y on its own on the left hand side. So then we can read off whatever is in front of the x becomes our gradient amount there, or gradient value. In this case, the gradient of that original expression, after we muddled around with it to get it into the right format, we can just read off now that the gradient is 3 over 2. Question 7. Does the point 2, 6 lie on the line y equals 3x plus 1? Our answers will be yes, no, I can't tell, or I'm confused. Alright, the rule is a point lies on a line if the x and y values of the point make the left hand side of the expression and the right hand side of the expression work properly. So they're equal to each other. We're going to sub in an x value of 2 and a y value of 6 into that line expression of y equals 3x plus 1 and see if it makes the left hand side equal the right hand side. Let's have a look. So y equals 6, that goes in where the 6 goes in where the y is. And for the x, we've replaced an x with a 2. And so it's 3 times 2 instead of 3 times x there. And we've got the plus 1. So let's see if that makes sense mathematically. It's 6 on the left hand side, we get 6 plus 1 on the right hand side. Now I'm here to tell you that 6 doesn't equal 7 very often. So that means that the result there was the left hand side doesn't equal the right hand side with those coordinates and that linear expression. So that tells us that no, that point does not lie on that line if we drew it all out and graphed it and everything. So a point lies on a line if the coordinates make the equation, in the way I say it, if those coordinates make the equation work properly, so they make the left hand side equal the right hand side, we know that that point lies on the line. Not in this case though. Question 8. Which of the following lines are parallel to y equals minus 2x plus 7? Our options are minus 2y minus x equals 7, y equals minus 2x plus 5, 3y minus x minus 7 equals 0, or perhaps y equals 7x minus 2. Alrighty, parallel lines have the same gradient, so we want a gradient of minus 2. This linear expression was in the right format, the y equals mx plus b format for just reading off the gradient, which is the value in front of the x. In this case it was minus 2, so our gradient is minus 2 of our original line there. So we want a line that's got a gradient of minus 2 as well. And we can spot that the line for option B has a gradient of minus 2 as well. So y equals minus 2x plus 5 is parallel to our original line expression there. Question 9. Does the line y equals 4x minus 2 pass through the point 3, 10? The line passes through a point if the x and y values of the point make the left-hand side equal the right-hand side. So we're going to take the x value of 3 and the y value of 10, they're our coordinates. They're our values we're going to put in and see if it makes y equals 4x minus 2 work properly, or create a left-hand side equals a right-hand side situation. So let's see. So for the y, we want to replace it with the 10 value. For the x, we want to replace it with the 3 value from the point there, and see if that makes sense mathematically. So we've got 10 on the left hand side, 4 lots of 3 is 12, minus 2, and then we get 10 equals 10, which I'm quite happy with. That makes the left hand side of that expression equal the right hand side, and that's kind of like a successful substitution there. It all made sense, so we can say yes. The line y equals 4x minus 2 does pass through the point 3, 10. Question 10. The equation of the line below on the diagram is y equals 3x plus 4, y equals 4x plus 3, y equals minus 4 on 3x plus 3, or y equals minus 3/4 x plus 3. Alrighty, a few moving parts here. Let's have a look. A line leaning to the left, like our original, has a negative gradient. So the gradient is the number in front of the x there. So I think C and D are our only options for our answer here, because the line leans to the left. Now we can find the gradient on our original line by having a look at rise over run. So this one, if you look at the values when the line crosses the y-axis of 3 and where it crosses the x-axis of 4, that kind of indicates that it rises 3 for every 4 that it goes across. And so that gradient is 3/4, which matches up nicely with option D there. And also, as a double check there, we also have a y-intercept of 3, and when it's in y equals mx plus b format, our lines there, our final number should be a 3. So that matches up nicely for option D, that had all the boxes ticked there. So our final answer, the equation of the line below, is y equals minus 3/4 x plus 3.